Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Apache Ozone is an open-source object storage system designed to handle billions of objects efficiently. Unlike HDFS, which is optimized for large files, Ozone excels at managing massive numbers of small to medium-sized files. It's part of the Apache Hadoop ecosystem and is built to scale horizontally. With its S3-compatible API, it integrates seamlessly with existing cloud-native tools and frameworks. Traditional HDFS struggles with scalability when dealing with billions of small files. Apache Ozone solves this by decoupling namespace management from block storage. This allows it to scale more effectively. It also provides an S3-compatible API, enabling compatibility with a wide range of tools. Ozone is designed to work in hybrid and cloud-native environments, making it a future-proof choice for data engineers. Apache Ozone's architecture is composed of 4 key components. The Ozone Manager handles namespace operations like creating and deleting volumes, buckets, and keys. The Storage Container Manager manages block placement, replication, and container lifecycle. Datanodes store the actual data in containers. Recon provides a web UI and REST APIs for monitoring and metadata insights. The Ozone Manager, or OM, is the namespace layer of Apache Ozone. It's responsible for managing volumes, buckets, and keys, the logical hierarchy of Ozone's object model. OM exposes both native Ozone APIs and an S3-compatible API, making it versatile for different use cases. It ensures strong consistency using RADIs, a Raft Consensus Protocol implementation. The Storage Container Manager, or SCM, is the block layer of Ozone. It manages how data blocks are placed and replicated across data nodes. SCM also handles container creation, deletion, and lifecycle management. It performs node and pipeline management to ensure fault tolerance and optimal data distribution. This makes Ozone highly scalable and resilient to failures. Data nodes in Apache Ozone store data in containers, which are the fundamental units of replication. Unlike HDFS blocks, containers can hold multiple objects, improving metadata efficiency. Datanodes support various storage types like SSDs and HDDs, enabling cost-effective storage strategies. This architecture makes Ozone both scalable and fault-tolerant, capable of handling petabytes of data. Recon is Apache Ozone's monitoring and metadata insights tool. It provides a web-based UI and REST APIs for administrators to monitor cluster health. Recon tracks container and pipeline statuses, helping identify issues before they impact performance. It also offers insights into metadata distribution and storage utilization, making it easier to optimize and troubleshoot the cluster. This diagram shows the interaction between Apache Ozone's core components. The Ozone Manager and Storage Container Manager communicate with datanodes over gRPC. Data flows through pipelines into containers stored on datanodes. Recon monitors the entire system, providing insights into performance and health. This architecture is designed for horizontal scalability, allowing clusters to grow seamlessly. Apache Ozone uses a hierarchical object model consisting of volumes, buckets, and keys. A volume is the top-level namespace container, often used to isolate tenants or projects. Buckets group related keys, similar to directories. Keys represent individual objects or files. This model mirrors S3's structure, making it intuitive for users familiar with cloud object stores. Apache Ozone provides native S3 compatibility through its S3 gateway. This allows users to perform standard S3 operations like put, get, and delete using familiar tools and SDKs. The S3 gateway translates these requests into Ozone native operations, making it easy to migrate from or integrate with existing S3-like systems. This compatibility is crucial for hybrid and multi-cloud strategies. Apache Ozone supports multiple storage classes, including standard and reduced redundancy. This allows administrators to configure replication factors based on data importance and cost considerations. For example, frequently accessed data can be stored with higher replication, while archival data can use reduced redundancy. This flexibility enables efficient tiered storage strategies while maintaining data durability. In Apache Ozone, data is written through replication pipelines, which define how data is distributed across data nodes. Ozone supports RADIS pipelines for strong consistency and standalone pipelines for simple setups. These pipelines are managed by the Storage Container Manager, ensuring data is consistently replicated and durable. This approach enhances both performance and fault tolerance. Containers in Apache Ozone are logical units that store multiple objects. Unlike HDFS blocks, which are large and sparse, containers are compact and efficient. The Storage Container Manager handles container placement, replication, and lifecycle. It also supports container balancing and healing, ensuring optimal performance and data integrity. This design significantly improves metadata efficiency. Apache Ozone includes robust security features to protect data at rest and in transit. It supports Kerberos authentication for secure access and TLS encryption for data in transit. Access control lists, or ACL, allow fine-grained permissions on volumes, buckets, and keys. Additionally, Ozone integrates with Apache Ranger for centralized security policy management. Apache Ozone is designed for high performance across a variety of workloads. It delivers high throughput for large datasets and low latency for small object operations. Its efficient metadata handling allows it to scale to billions of objects without performance degradation. These features make it ideal for modern data lake and analytics use cases. Apache Ozone is an excellent choice for data lake storage. It supports both structured and unstructured data, making it versatile for analytics workloads. Its S3 compatibility allows seamless integration with tools like Spark, Hive, and Presto. With scalable architecture and support for tiered storage, Ozone provides a cost-effective solution for storing and processing massive data sets. In machine learning workflows, Apache Ozone excels at storing training datasets and model artifacts. Its S3 API is compatible with popular ML frameworks like TensorFlow and PyTorch. Ozone's scalability supports large model files, while its metadata capabilities enable versioning and lineage tracking. This makes it a strong backend for end-to-end ML pipelines. Apache Ozone is also well-suited for archival storage. Its support for reduced redundancy storage classes makes it cost-effective for cold data. Organizations can use Ozone for compliance, backup, and long-term retention. Integration with lifecycle policies allows automated transitions between storage classes, optimizing cost and performance. A major e-commerce platform adopted Apache Ozone to store and analyze petabytes of user interaction logs. By leveraging Ozone's S3-compatible API, they seamlessly integrated it with their existing analytics stack. Tiered storage allowed them to reduce costs by placing older logs and reduced redundancy storage. This real-world example showcases Ozone's scalability and cost-effectiveness. Compared to HDFS, Apache Ozone offers superior scalability for billions of small files. Its S3-compatible API contrasts with HDFS native API, making it more accessible to cloud-native tools. Ozone's decoupled architecture separates namespace and block management, improving performance and flexibility. These features make it better suited for modern, distributed environments. While Amazon S3 is a leading cloud object store, Apache Ozone offers an open-source alternative. It can run on-premise or in hybrid environments, giving organizations more control. For large-scale deployments, Ozone can be more cost-effective. It also allows customizable replication and storage policies tailored to specific business needs. Apache Ozone supports multiple deployment models to suit different environments. It can be deployed on-premise for full control or in hybrid cloud setups for flexibility. The Ozone operator enables Kubernetes integration, simplifying containerized deployments. Whether on bare metal or cloud VMs, Ozone adapts to your infrastructure needs. Getting started with Apache Ozone is straightforward. You can download it from the official Apache Ozone website and set up a local cluster for testing. Use the Ozone CLI or S3 API to perform operations like creating buckets and uploading files. The project's documentation and community forums are great resources for learning and troubleshooting. Apache Ozone provides multiple interfaces for interaction. The Ozone CLI is ideal for administrative tasks like managing volumes and buckets. The S3 API allows integration with standard tools like CLI and SDKs. REST APIs enable custom tooling and automation. This flexibility ensures that developers and administrators can work with Ozone in the way that suits them best. Monitoring and troubleshooting Apache Ozone is made easier with Recon's web UI and REST APIs. JMX metrics provide insights into system internals, while logs offer detailed diagnostics. Integration with Prometheus enables alerting and advanced monitoring. These tools help maintain cluster health and performance in production environments. Apache Ozone is an active project under the Apache Software Foundation, with regular releases and updates. It has a growing community of contributors and users. Integration with tools like Spark, Hive, and Ranger makes it a natural fit for the Hadoop ecosystem. Several major organizations already use Ozone in production, validating its maturity and reliability. The Apache Ozone roadmap includes several exciting developments. Enhanced multi-tenancy support will improve isolation and resource management. Performance optimizations for small files are underway. Better Kubernetes integration via the Ozone operator is planned. Additionally, support for advanced analytics and AI use cases will expand Ozone's applicability. There are many resources available to learn Apache Ozone. The official documentation is a great starting point. Community forums and mailing lists offer peer support. Hands-on tutorials and examples help you get practical experience. YouTube videos and conference talks provide deeper insights from experts and real-world users. In an upcoming hands-on demo, we'll walk through setting up a local Ozone cluster. We'll create volumes, buckets, and keys using the CLI. Then, we'll upload and download files to see Ozone in action. Finally, we'll use the S3 API with CLI to demonstrate compatibility. Stay tuned for that detailed walkthrough. To wrap up, Apache Ozone is a scalable object storage solution designed for big data workloads. Its S3-compatible API ensures broad tool support. The decoupled architecture improves performance and scalability. Ozone is ideal for data lakes, machine learning pipelines, and archival storage. It's a powerful tool for modern data engineering. You should consider Apache Ozone if you need to store billions of small files efficiently. Its S3 compatibility makes it easy to integrate with existing tools. If you're working in hybrid or on-premise environments, Ozone offers flexibility. As an open-source solution, it provides a scalable alternative to proprietary object stores. Apache Ozone may not be the best fit for small-scale deployments with few files. If you need a fully mature and battle-tested solution, HDFS or S3 might be better. Organizations preferring fully managed cloud services may find Ozone requires more hands-on management. It also demands resources for setup and ongoing maintenance. When adopting Apache Ozone, avoid common pitfalls. Don't ignore replication and storage policies, they're key to cost and performance. Plan for metadata scalability to prevent bottlenecks. Always configure security properly, including Kerberos and TLS. Finally, don't overlook monitoring and alerting, they're crucial for production stability. To get the most out of Apache Ozone, follow these best practices. Use appropriate storage classes to balance cost and performance. Enable encryption and access controls for data security. Monitor container and pipeline health regularly. Automate backups and lifecycle policies to reduce manual overhead and ensure data durability. Performance tuning. Apache Ozone involves several strategies. Tune container size and pipeline count based on workload characteristics. Use SSDs for metadata-heavy operations to reduce latency. Optimize network and disk I/O settings for your environment. Monitor JMX metrics to identify and resolve bottlenecks proactively. Securing Apache Ozone starts with enabling Kerberos for strong authentication. Use TLS to encrypt data in transit. Configure access control lists or ACL to manage permissions at the volume, bucket, and key levels. For centralized policy management, integrate with Apache Ranger. These steps ensure your data remains protected. Thanks for watching this deep dive into Apache Ozone. If you found this video helpful, please give it a like and subscribe for more big data tutorials. I'd love to hear your questions or use cases in the comments below. Don't forget to check the description for links to resources and further reading. See you in the next one. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.